lunch break and the break on the global Pydata Global. We're here to introduce our next keynote speaker, Lisa Armini. Lisa is a distinguished engineer at IBM. She leads IBM's data and AI platforms research. So let's give a warm welcome to Lisa.
Thanks, Abby. Thanks, everyone. Better? All right, there we go. Okay, so how many of you have heard of IBM Research? Are you familiar? Oh, wow. Okay, fantastic. All right. So IBM Research, you may have known about us from our Jeopardy days, like the first computer to win Jeopardy. More recently, you've heard of the quantum computing and the breakthroughs that we're making there. IBM Research has a, like a really cool mission, right? So our mission, we have two prongs to our mission. It's be the organic growth engine for IBM. In other words, try to go and figure out what's next in tech, and then try to, build it into something that, that IBM can leverage, that our customers, clients, enterprises can leverage. And then the second thing is like create what's next in computing. And by computing, it's hardware and software is what we're always working on. And for that reason, and because our computers are, they need to be deployed in enterprises and a vast variety of different types of enterprises, we need a lot of different disciplines that are working. So, cloud computing, artificial intelligence, quantum computing. So literally hundreds of disciplines that kind of come together for some really interdisciplinary research. So also IBM, you probably know, but like, in terms of, we're not a consumer, so we don't do social media, any of those sorts of things in terms of what we're building, but we do process about just under 90% of credit card transactions annually and about 4 billion flights annually. So, so very into the enterprise computing. IBM Research is a pretty significant lab, so 3,000 researchers worldwide. We have labs across the world, 80 years. We do take on a kind of a more academic or traditional view of research. So, our researchers publish in, top academic conferences, journals. You can see, 6 Nobel laureates, Turing Awards, national medicine. I don't have a Turing Award, but I have been working at research for a very long time, and I really enjoy it. And hopefully it's still a good talk, even if I don't have one of those. Okay, so now we switch into the topic, and I will do just a little bit of kind of level setting on AI and data, just so we're using the same terminology, and then I'll get into more of the meat. So. I'm sure everyone here is well aware of the generative AI boom that's happening right now. Large language models, so Claude, ChatGPT, Gemini, Llama. IBM also has our own models as well, so the Granite series of models. We tend to build small and medium-sized models that are more for the enterprise, making sure that the data is good and valid to be used and okay for enterprise settings, make them very customizable to the enterprise. There's also even smaller, very tiny models, So there's this whole range of powerful models that are happening, and it's just shocking for someone, like I said, that's been working in AI for such a long time, in terms of the breakthroughs that are happening. So I think this particular chart is nice in terms of trying to show it. What it's showing is it's basically showing from when we start work on a particular benchmark to when it's actually performing at human levels, right? So what's interesting is you can see, like, things like, handwriting recognition and these very elementary types, they literally took decades before the models could get to what human performance is. And now look at the curves, right? The curves are almost straight up, right? So in terms of, being able to, the community, the scientific community is putting these benchmarks out here. Clearly, they put them out there because they think, this is something that's really a breakthrough if we're able to accomplishment. These are things, the more recent ones, reading comprehension, predictive reasoning. So these are things that they're not trying to create easy benchmarks. But the thing is that the technology is just moving so fast that we're able to bring them up to human abilities very quickly. Now, on the other hand, obviously these are narrow, so they're not they're not AGI benchmarks, right? They're really trying to test a particular aspect of the model and see how well they're doing at that. So really a dramatic change in terms of the breakthroughs that are happening there, and the rate and pace at which the technology is growing. There's also a lot in the news in terms of just the sheer cost of, computing and energy that it takes to build these models. But one of the things that people may or may not realize is that the actual cost per inference is dropping quite dramatically as, we're building better systems, we're building better algorithms. And so it's not, even though we keep, because the models keep getting larger and larger, it keeps taking more and more compute, more and more data, but nonetheless, the actual costs are coming down, and you'll see that continue to come down. So, and then just kind of, I try to balance it out in terms of a business terms, right? So this is a projection, obviously, but projection is 16 trillion by 2030, right? That's astounding in terms of a number. I try to always also balance it a little bit in terms of, there are some dark clouds that are looming, more near term, right? There's, scams, misinformation, bias, discrimination, cyber attacks, all of these things that are, the researchers are also, and researchers, developer, the community is also working to try to mitigate and address. Longer term, I would say these are the ones that are not necessarily substantiated yet, but because they're, people consider them potentially existential threats, they are something that people in the AI safety field especially are starting on now. Like, what happens if we build these machines and suddenly superintelligence, they outsmart us, right? They do things that, we don't realize are in some ways malicious. You see this already sometimes with, you ask some of the agents to go and do something, and then they maybe find a way to kind of break through a system as opposed to truly solving the problem that you've asked them to do. So it's true that it's something that we have to take seriously. On the other hand, it's incredible progress. It's exciting in terms of what's coming through, and so we'll continue to you'll continue to see the the breakthroughs coming here. Okay, I also want to just level set a little bit in terms of some of the terminology, right? So the evolution here that you've seen, like we went, it used to be that machine learning was primarily predictive, and in some cases some prescriptive algorithms as well, but primarily predictive types of algorithms. And then generative models, LLMs, started to come out, and they can actually generate. They can generate natural language. They can generate, go from one form of speech to another form of speech, or from text to speech, or vice versa. So they're generating images and so on. The next thing is obviously just kind of building on that ability to generate is AI that can chat with you. So you can actually have a conversation with it. You can get answers. It's going to go and retrieve information. It's going to try to bring that information back to you in a form where it's answering your questions and so on. And then the most recent is AI that can do for you. So this is why agents are so exciting for people, because it changes a couple of things, right? So one is that, without agents, or, if you're really doing what is intended for these agents, then you're leveraging, the context, the environment within which it's operating, and the LLM to try to dynamically control the flow through an application or a workflow. That's different. That's very different from the way we used to build programs. And I'll talk more about that when I start showing some examples in the data space. They're able to, the whole idea is to enable them to autonomously make decisions and take actions, on behalf, and to self-correct as they're navigating through that path. So this is a significant change. There's single agent assistance, multi-agent assistance. The other thing that I wanted to just note is that sometimes people are using agents to build assistance. But what I'm really talking about when I'm talking about the agents, I'm talking about agents that really have that agency to go and solve problems, to do research, to make decisions, and so on. So, okay, now we're going to switch a little bit into the data landscape, right? So a lot is changing for data management space. And it's not just the huge volume of data that's being used to, to train the frontier models or these sorts of things. This is data across the board, I think is changing, right? So one, unstructured data is not new, but its prominence, right, is relatively new, right? The amount of information we can get from unstructured data, our ability to actually exploit and leverage that in productive ways. It used to be, it wasn't that long ago when you would, take the images and these sorts of things and people could watch them, but the machines weren't really reasoning on them, they weren't really generating them and so on. So, unstructured data is really starting to take center stage here in the demand that it's placing on these data management systems. As an example, another example is that, databases were structured data. Data, if you think of all of the evolution for, for structured data, databases, and then data warehouses, and then data lakes, and then data refineries, data lake houses, and all these sorts of things, those are primarily geared towards structured data. The later ones did allow you to put in unstructured data, but a lot of that was really geared toward structured data. Okay, so also new workloads, right? This in terms of the workloads, right? So we see already that instead of, applications that would generally formulate a query and then send that to the database and get a response back, now it's RAG, retrieval augmented generation. So in other words, where you go and, retrieve information from the database or the content store or whatever, and you pass that into the prompt for the LLM, and then the LLM is able to then generate something with that context. And that's what helps it, bridge that gap where the LLMs may have been trained on older data or data that's not specific to your context. You want to make sure they're taking advantage of the newer data and data from the context. But there's something really interesting about, the fact that these emerging at scale will also change the profile of how they get access to that. So I'll talk about that in a moment. New user experiences, right? So more and more people are starting to use co-pilots to help with development, but also to help with some of the data analytics types of tasks. So data analytics, business intelligence, these types of tasks, you're seeing more and more in terms of AI being brought in to try to help kind of co-pilot that. Another one is kind of a new interaction style. So it used to be that, when you'd have a query, a lot of times applications that were developed would decide on kind of what those queries would be. And then, it would just be kind of repeated every time somebody entered a certain space in the application, that query would go against the database, and that was that. Okay. The AI agent interactions with the database look different because what they're having to do is they can't just form a query, from natural language to get go, because generally that natural language is complex, it can be ambiguous. What's in the repository is not necessarily known. So the agents need to try to bridge that gap between probing the database, probing the structures of the database, and then from those probes, then it can start to figure out, okay, this is how I'm going to formulate my query. This is how I'm going to resolve ambiguity that's going back to the user question. So that's a very different, it's much more, speculative, kind of repetitive, smaller, and it's more dynamic. Old queries used to be kind of the same queries again and again. People would test them, train, and make them efficient. Now it's much more rapidly evolving and changing. Also, AI is becoming more capable of being embedded within these data management systems and then adapting and learning from that. So the learnable components there in terms of being able to kind of learn, okay, how should I do some of the parameters within my database or my content store has been there a little while. But some of the more recent papers, which are even more exciting, they're starting to realize that with AI, you can probe the design space of, software that would be considered kind of kernels of the database and try to find the most efficient, router or query optimizer or these sorts of things. So that is, that's amazing because that has always been in the domain of deep experts that really understood how to do query optimization or dynamic routing or these sorts of things. So to have the agents, and I want to be a little careful. I'm saying, I'm letting you know this is kind of what's happening and this is what's changing. But the accuracy rate on some of this, low 20s, 30s, climbing up 40s, 50s, right? So, it's moving up there, but these are on the horizon. There are benchmarks out there for them, and people are really starting to go after this. So a lot changing in database, data management, content stores, and just the data space in general. But there's still some things that just aren't going to change, right? So the first one is price performance is critical. It always has been. It always will be. It probably becomes even more critical just because of the scale of these systems and the rate and pace you want these agents to operate at. Open source is critical as well, right? This enables people to kind of bootstrap quickly, enables us to interchange components. We've gone from having what used to be very siloed vertical data management systems to where people put together pieces. They put together Iceberg with Presto, with Velox, and so they're kind of putting together these different engines in a different way. So that's also very exciting and absolutely critical for the continued growth. And then hybrid data is still critical, right? The fact that you're going to need to take advantage of data in different places. So exciting things that are forcing changes in the data management space, but still, some stalwarts in terms of things that are critical. Okay, so now let's talk a little bit more about AI for data management and operations. So this is kind of a traditional, data stack, right? So you start with, storage at the lowest level, Iceberg, Parquet. So these are, systems that actually store the, the tables and so on. You may need some caching between here. Then you have the compute engines, the query engines on top of that, and then above that are the query interfaces. So this is meant to be, kind of a standard notional stack. Maybe everyone's isn't exactly like this, but that's the idea. Okay, so what's kind of interesting and changing? Previously we had already been looking at how do we kind of infuse some of the AI into this, like I talked about, being able to have these learnable components within the system and so on. But what's also happening that I think is interesting is that, consider this, there's kind of a complementary stack to this stack. Note that I've inverted it because to me it makes more sense to kind of say that if you were going to think about the human tasks that are required to configure, manage, run this stack, then you start with designing and implementing the storage and infrastructure. You start with then trying to understand how to optimize that for the particular workload that you expect. You go and try to discover the data sources that you need and try to bring them into this. You may need to do things like enrichment with additional metadata to make the search work better. Then you start to create these data flows that do various forms of transformations of the data to get it into the form that you want. And then, there's the need to remediate the data flows because this is what's populating the data sources that all the applications are running on. You may need to make sure governance is covered. And then the whole point is that you want to be, kind of at that top layer being able to uncover insights, support your applications, and all these sorts of things. So I think it's what's interesting is that this set of tasks, right? If you think about it and think about everything we were just saying in terms of agents being able to start take on some of the things that humans were doing and so on, it's a very fertile ground for AI and for agents. Okay, so. Sometimes people, that in terms of the task, people may or may not kind of understand the complexity of these systems. So before I start talking about the AI that we're working on to try to address that, I want to try to show what it looks like. So imagine, that you have some request to build out a data stack. Then, there's and these may not each be a different person, but notionally they're kind of doing a different task, right? So somebody's got to figure out the infrastructure. And then somebody's got to go and get the data, start to prepare that, make sure it's going to be on budget, it's going to fit with the requirements of the enterprise and so on. Okay, then we have to set up the airflows. Then, okay, somebody is actually doing, maybe some time series analysis or something like that. Okay, it's not working well enough. Okay, well, I need to go get some more data. We go maybe all the way back to acquiring even externally. Okay, now I need to update the infrastructure. I may need to add some VMs to try to make sure things are being reliable. Okay, are we watching out for compliance? Okay, now things are maybe becoming flaky. I need to keep these going. So there's. I just wanted to like kind of make the point that there's a lot of work to try to manage that data behind the scenes that a lot of times people don't necessarily see. Okay, and I think sometimes with AI and AI talks, people do something like as a demo, and they sort of like prompt the model, and it does something. Like you say, okay, if I wanted to create a new application, I want it to be able to answer questions about financials of companies and maybe my 401k and these sorts of things. And you ask the LLM, you say, what kind of data should I go and get? And it comes back, and it comes back with pretty good data sources. And so sometimes people are kind of saying, okay, I think I can do all of that with prompting. All of those things that I just kind of showed. I can just prompt the model, and it's going to give it. And it might do fairly well at some things. But I just wanted to kind of like show, if you look at the complexity of these tasks. I may be preaching to the choir here. I realize a lot of you are data professionals, but this is not easy stuff, right? It's quite complex in terms of what needs to be done. So I apologize, it's a little bit small, but it's like architect and scale high performance data platform, hundreds of millions of multimodal data points, microscopy images, genomics, transcriptomics, other omics, Postgres, Milvis vector databases, all of these sorts of things. So a lot of complexity there. Okay, all right. So this is our focus. This is our focus of how do we build AI to try to help with data platforms, and it really breaks down into three areas, right? So we want to build the large scale system, or we want to take advantage of large scale data systems. This is where things like, text to SQL or, RAG or these sorts of things come into play, right? I'm trying to leverage the data systems, and I need AI that's going to help me with that. And the big focus there is on accuracy, cost, and latency, right? Because if you think about it, you can, you have too many inferences going back to the LLM and these sorts of things, and costs can get out of hand very quickly. Latency can skyrocket and so on. The other part that we focus on is can we build the data systems, right? So can we actually build the sorts of stack that you saw on the previous one? Can we, from a description of the types of data that I would want, can I go and find that data, transform it into the form that I want, add the metadata for it, set it up so that I'm going to be able to continue, keep it refreshed. And then the last part is to actually optimize, the data system. So enable, error remediation, optimization, redesign by leveraging observability to try to, continuously improve the system. So, okay. So it sounds a little difficult, right? I'm gonna, create AI and agents. It's gonna take over kind of building out that whole stack, managing the whole stack, getting the insights from it. The systems are clearly not there yet. However, it's important to note that this transformation is already happening, right? And it's been happening actually for a couple of years, right? So we're already using generative AI to you get a bunch of data in, it's extracting, understanding what are the key concepts within this. It's trying to link across those concepts. It's trying to bring it into the right form. It's trying to create semantic information that actually describes this data, links it to a glossary, enables better search, enables better governance. So that's been there. That's been there, for at least a few years with Gen AI. It got a lot better. There's a big step change from the old systems that were using kind of classification methods to the new that's using the generative AI. Secondly, the data integration products are, they're already using AI to create these assistants that will help you, step you through creating your data flows and doing some diagnosis of data flows and so on. And then also, there's already lakehouses, databases, BI tools where you can ask your question in natural language of the database, and it's going to come back to you with some LLM synthesized answer that might be on a combination of information it's retrieved from structured data and unstructured data. So these things it's already happening. It's not everything is in the future, but I want to talk a little bit more about how we keep evolving. Another example, frankly, and I don't think you're going to be able to see this well, but I'll just kind of kick it off, right? So another example is that there's a big task of right now, if you want to make sure your data is being kept, up to the quality standards that you need, then a lot of times, humans would go out there and write these data quality rules to try to do some checks or maybe data quality remediation types of rules. They do that in SQL, they do it in Python. What's already there in some products is the ability to take natural language descriptions and the data, the schema, and then be able to generate the data quality rules, or take data quality rules and generate the natural language description of those data quality rules. These are getting better and better in terms of being able to look into the data and estimate, okay, I think the format should be this, and I can generate the rule from that, or I can look at the glossary and understand what this should look like, and I can generate the rules from that. So a combination of natural language as well as looking at the schema, maybe looking at the glossary, looking at the patterns within the data. So this is advancing fairly quickly in terms of the data quality. Another area is, again, just to kind of show you some of the things that are already in play. You have errors or issues that are detected in systems, and so now the AI is taking a look at these kind of what you would get in the actual log, and then trying to it can generate a better description of what it thinks is going on based off of both the issue and by looking at other things that are happening in the system. It can also generate, I don't know if you can see it here, but it can also generate root cause analysis, what the expected root cause of this is. I want to also be a little bit, so you can see it kind of now, it's working on the root cause issue, trying to generate better natural language descriptions of what's happening within this. And so these are, like I said, this is kind of, okay, these are things that are kind of more recently being brought in, and that's Gen AI. You suddenly see something that's working a little bit better, giving you more information, better description, these sorts of things. Generally, it's some Gen AI behind that. Okay, but that's not really our goal, right? What we really want to get to is this idea of going from automation, just automating steps, to how can we make this a much more autonomous stack that's able to continue. So like how would that work, right? So the idea here is we have a little bit of an example, like, so suppose you have some new startup or project and they need a data stack for an AI app. So one of the things that we see is that people are creating these apps. I have this new Ask HR app, or I have a new Ask Sales app, or all of these different types of apps that are starting to be stood up. But then you got to go get the data and bring it ready, right? And you see startups that are doing this as well. So this one's saying, okay, well, suppose there's a startup and it needs to create a data stack for a robo-trading app using public sources, market data sentiment, support agentic workflows on periodic 401k rebalancing. So the point is that here, I'm not asking for a question. I'm not saying, predict the stock or something like that. I'm saying, go set up the stack for me and get this ready, right? So, okay, so it kind of flows through the different agents, similar to what you saw as it flowing through the humans, but now it's kind of flowing through the agents. But first time through, it's getting maybe poor analytical performance, but then we can go back in the messages, request that it's doing better, and then the supervisor agent is getting better. So this is kind of a notional, cartoon of how this has happened, and then I'm going to show you, how it's working in real life. This is just kind of saying there's also subtasks that need to be handled autonomously as well. So setting up the stack is one thing, and then coming back and setting up maybe some of the data products within that, getting those ready also to be managed autonomously. Okay, so let me show you a little bit of a demo here. Okay, so let's see if I can get this started, see how I'm doing on time as well. Okay. Okay, so same sort of a question. So normally, how does this happen today? Like a human goes out here and they start looking at on the, in the database or the lakehouse, they try to find, with normal search, you can find tables or, documents and these sorts of things. They start to look through it. They're looking for, are some of the fields right? They recognize some of it may be text fields, so it's really more semi-structured, right? So we've got a mix of some things that are structured and unstructured. And so, then the human would take that ordinarily and then start trying to put that into it. So, okay, so now let's try to switch and how we're doing with data ops, right? So same thing, there's a request for, at this point, it's just kind of the data product piece of it. It's not the whole stack. And you can see it's getting queued up as a good issue. The data ops agent is listening for the good issue. It's based off of that good issue, then it's generating a plan. It asks the human here to confirm. And then based off of this, what it's going to do in this case is it's taking that description that you saw first, and it's, we use the LLM to imagine, a schema that would be ideal. And then from that, we start trying to populate that schema from the tables and the documents and all these sorts of things that I can find. And then once I do that, then the model, asking the model to help in terms of taking a look at some of the natural language fields, helping me to then extract and bring those into structured fields, and then to prepare this data asset. And so, okay, so that's a first part, and you can kind of see the way that it's creating, it's finding, because we know they want to do analytics on like investment strategy and so on, so that's buried in the natural language. Try to extract all of that out. And so then it says, okay, why don't you go and, it comes back to the human, at this point, you should maybe do some evaluations of this, right? So how do we, the hard part actually is not generating the data product. The hard part is, how do I know it's a good data product, right? That's a mess. I can go get a bunch of data, and then how do I know it's good? So one of the ways that we've been working on is to basically say, well, what if, if I take that same topic and I take that imagined schema that I came up with, could I generate questions? What kind of questions might I ask on that topic, with this kind of data? So we generate natural language questions for this, and then we run the questions, against the tables that we have. And then, what's running in the background is, a system that's also looking at what issues are happening and then trying to cluster those issues and then try to, again, bring that back to the human in a way that they can, solve them more easily. So what we're trying to do is we're kind of trying to flip how things are done. So let me just kind of go to the next one a little bit because I want to watch the time. 17, I end 40, 45. What time do I?
About 13 minutes.
13 minutes, okay, thanks. Okay, all right. So, okay, so what you were seeing was, I get this type of topic description, and then somehow I need to go from that. And what I'd like to do is not just create a bunch of tables or a bunch of documents or, a bunch of files, these sorts of things. I'd actually like to create the metadata that goes with that. Because if I do that, then I know that basically I'm not just doing this one time, but I'm able to monitor and see, like, I talked about generating the questions and see if those work against this. Tomorrow, I can check again and see if those questions are still working, for example. So how do we do this? It can't just be we go and get all that data and just put it into form. It has to be this iterative process of trying to discover relevant data, try to generate, hypothesize what would be a good asset to generate, then try to assess it, and then keep coming back. But then how do you assess it? Like, how do you know you're getting closer to what you wanted? So this is what I'm going to show you in just a second. What I was just trying to show with this little part down here is that sometimes people refer to like a medallion architecture. It just means that you kind of, you have known states for your data assets. Like bronze is, I just got it into the system. Silver means I'm getting close, so it should be ready. And gold means, okay, ready for application. And so the whole idea of this bringing the data and the metadata together is to give you a way to get from bronze or silver into gold, and then to stay there, to be able to kind of keep checking that and making sure that's the case. Okay. Okay, yeah, so how do we do that? How do we assess it? Because the agents have to do it autonomously. They can't keep coming back to the human and saying, is this good? Is this good? Is this good? That's not going to work. So what you can kind of see here is what we do is these are examples of tools that we can use. So I talked about Well, we can look at the topic description and we can look at the schema. We can generate natural language questions that seem like they're relevant for that. What's nice about that is that a human can look at those questions and say, yeah, that's the kind of questions that I would want for my application or not. So we can generate the questions. Once we generate those questions, we can then generate follow-up questions. Follow-up questions meaning kind of probing deeper into a particular topic area. And I'm going to kind of go through which each one of these is giving. So the first thing is, if I'm generating questions, okay, it's just building up a question count. But then what I can do is, if I'm generating, so I generate the questions, the natural language questions, and then I generate the queries that go against the back end. And when I have those queries, then I can start to look at metrics like, well, am I covering the tables? In other words, are my queries hitting the tables that I put in there? If none of the queries are hitting the tables, then either those aren't good queries or they're not good tables, and I can keep trying to evolve it in that way, right? I can also look at, the questions, the clusters of the questions, and decide, okay, am I covering the topics that I really wanted to cover? So I can look at the number of topics generated. What I'm also trying to do is, if I'm generating these natural language questions, and these look like these are ones that should be valid, I generate the SQL, but I'm generating big, ugly SQL, big, hairy SQL, very long query length. It takes a long time to run. That's probably not a good asset, right? Either my questions are wrong, or I need to further transform the view, or get more data, or these sorts of things, right? So the idea is that you kind of take this, this much more iterative approach and just let the agents do it. Just let them go out. There's a supervisor agent. I'll just kind of show you how that's going here. There's kind of a, sorry. Yeah. Let me get this to run. Yeah, okay. So there's a supervisor agent, and what it's doing is it's looking at the state of the data product. At first, it's just the schema and what it's brought in. Then it starts to generate questions. It reruns. It looks at its metrics, and then looking at those metrics, it says, okay, what should I work on next? Let me go and try to reduce my query complexity. Let me try to cover more topics. These sorts of things. The agent is just sort of cycling through. We did a dashboard kind of a thing, because if we can't see how it's going if it's just the agent, and it's not so easy to see it with just text. So this is just to kind of show the evolution of what the agent is doing. But what you'll see here is, so it's looking, well, let me just explain this, right? So it's got like 50 or so questions. It's looking at the topic coverage. That was an inopportune time. Okay. At first, I'm not covering very many of the tables, and so it's going to generate some more questions to see if I can get further on that. What it's also going to do is, I'm just going to kind of skip because I'm running out of time. What's also going to do is it's going to kind of keep generating these questions, getting more of coverage of tables and columns. It's looking at what's the trend, because the trend is important, right? Because agents have to work autonomously, so they're basically looking for, are things like my table coverage leveling off? Am I starting to stabilize? Is my query complexity, did it go down? Is it starting to stabilize? That way, it can bring it to a level where it's stable, and either that's good enough, right? It's low and it's within the bounds that one would want, or, okay, this is as far as the agent was able to get it by itself, and it needs to go back to a human and say, hey, look, this is as far as I could get it. Maybe you can give me some more information about the topic or areas that I might get data or these sorts of things. But it kind of flips things on its head. So anyway, I think how am I doing? 7? Okay. 8 minutes. Okay, great. I get to do this one, and then I'll close it up real quick. Okay, so what's happening in the data management space, right, is that we think is really exciting is that we're trying to go along this horizon, right, like from having the user as an operator and having an assistant that helps them to do, our assistant or a co-pilot or these sorts of things that tries to help them to do things, to here where the user is more of an approver or a consultant or an observer. And we try to do that across those dimensions of use, build, and optimize. So we started with this, I have a natural language question. Okay. I generate, the query, I do the retrieval, the RAG, these sorts of things. The user is really the operator at that point, right? They're not getting that much help from the system. They didn't have to write the SQL, but they're still having to do a lot of the work. A little bit moving more towards this spectrum is what you just saw. give me a topic description, and I'll build the data product for you. Even further along was, give me a topic description, I'll figure out the data stack for you, I'll figure out also how to build the data product, and I'll be able to evaluate and assess it. Likewise here, what you saw for the data flow issue and being able to figure out the root cause and generate that description and so on, that's kind of more as the user as an operator. And what we're trying to do is bring it over here where the AI generates and executes a plan for resolution, right? It's able to generate data flow script repairs itself. It's able to what if alternative stack configurations. And then here for the natural language insights, we're looking to try to get that to be much more reliable and robust, much more interactive, being able to take on more sophisticated tasks in better insights, integration, and so on. So anyway, I do have a few others here in terms of if you want to learn more. There's a lot out here in terms of benchmark. This is what's advancing the field. If you look at the benchmark, then you know how people are trying to advance the systems. Likewise, the standards are a key part of this. So looking what's happening at the standards, I think data product contract, data contract, open lineage, these sorts of things will help the agents be able to, to interface with one another, interface with these systems. On the models, IBM has our models, the Granite models, they're out there, they're in Hugging Face, they're open weight models. Docling is for document processing. It's doing really well, actually, in terms of at one time, #1 repository of the day for Git and so on. So Malaya, I think there was a talk here. Malaya is something to help people to write applications, little AI applications a little better. There was a talk here. And then Agentics is something that's kind of in, it's an idea that, hey, look, instead of, with Malaya and with these others, you're kind of, the agent is calling tools, right? It has to figure out what's the tools. What if instead what we had is we had operators in Python that allowed us to just sort of request the transforms from one structure to another, and then the LLMs, in the back actually doing that. So this is another one that it's incubating, I would say, but it's out there. So a lot to do, and a lot of exciting things on the horizon, I hope. So wanted to stop and see if you guys have some questions. Yes. Do you want me to bring a microphone?
Maybe you could just repeat my question.
Okay, I'll try to repeat it, yeah.
I'll just, as I understand, the place where you envision this going is more of an iterative loop where throughout all the tech stack development, there are agents that are looking at all the other steps and the results, and it just sort of iterates on itself to build the perfect architecture and operational stack.
Yeah.
We didn't talk much about where the feedback is for that process, so that it doesn't drift
Yeah.
to be a perfect solution that no one wants.
Yeah.
When chess algorithms played themselves, they had this great feedback to say, well, I lost against myself, so this one is better. Where's the feedback in this loop that you were talking about?
Yeah. So it is harder, I would say, because like you said, that's a yes no, and that's how the RL algorithms win and so on. And this is kind of like more the challenge. But that's what I was actually trying to show with the the data product creation, the feedback loop there in terms of how good is this data product was, okay, is it answering the questions that I want it to answer? Is it, generating the SQL? Is that SQL, running at, within a latency that I would want? Is it causing a load on the, so the point is that, it is true that right now, it's not like the agents can just figure out and create the tools themselves. So what's happening is that, the humans, the developers or researchers are figuring out, okay, what's the right set of tools that I can give this agent so that it can assess how well it's doing, and then when it can't make progress, because things are not improving, and at that point it's going to have to go back to the humans, right? So I think that what I would also say is that I want to be really careful. Like if you don't have to be worried that this is coming tomorrow, So this is something that's very much in work, but and I think it's something that we will get to pieces at a time. In other words, we'll get to the data product, that autonomous data product, and we'll create the assets that enable it to just once we have that and we've generated the metadata like the quality scripts and the way to test against the right questions and all these sorts of things, then it becomes automation. It's less autonomous until something goes wrong, and that's why we also need like the optimizing part of the stack. But yeah, the signals are coming from a combination of basically the context that the servers themselves are giving us some signals in terms of errors that are happening, failures that are happening. So they give us some of the signals. So it's always context is one. We're getting some information as well from the tools, the metrics that the agents choose to try to then probe and understand that, and then trying to select how to get it onto a better trajectory. Okay. Okay, sorry.
Thank you so much, Lisa, for this amazing talk. I learned a lot, and I'm excited for what's to come.